Hello, everyone, and welcome to our webcast today on Secure ZOS FTP without JCL Changes. My name is Yvonne Wheaton. I will be your moderator today. I represent Software Diversified Services. Let me tell you a little bit about Software Diversified Services. We were founded in 1982. SDS is a Minnesota-based company that has a 35-year history of offering security, encryption, data compression, and network monitoring customer-centric IT infrastructure solutions. Software Diversified Services is a global leader in mainframe software and has been named to the Cybersecurity 500 list of the world's hottest and most innovative cybersecurity companies for the second quarter of 2017. SDS has licensed over 1,000 enterprise clients worldwide, including many Global 500 companies. SDS supports over 25 ZOS, MVS, VSE, and VM mainframe and distributed systems business software solutions. SDS is an IBM partner in development and an advanced member of IBM Partner World. So here's our agenda for the next 50 minutes or so. Let me introduce your speakers to you as well. Stu Henderson will be presenting Securing FTP Cross-Platform. Stu will cover the history of FTP and describe the exposures with file transfer, how to think about FTP security in your organization, and issues that may be of importance to you when you consider implementing and securing FTP. Stu Henderson is one of the foremost ZOS security experts. Since 1990, Stu has directed his own firm, the Henderson Group, which provides computer security consulting and training in a variety of technical areas. Mr. Henderson is an experienced consultant who specializes in effective computer security for IBM mainframes, Unix, and Windows. Colin Vandeross will discuss the case for secure FTP and provide an overview of VFTP and SSH. Colin will touch on why folks need to secure their FTP in light of recent exposures. Peppered in his presentation as well as at the end, Colin will show you the Vital Signs FTP-SSH collaboration software solution. Colin is a senior systems engineer here at SDS and has over 25 years experience as a customer at a large bank as their network systems programmer responsible for network transfer and security file solutions. He's been at SDS for over 9 years now, focused on network software solutions and security solutions. Following Stu and Colin, we're going to have that Q&A session, so go ahead at any time and put questions in the question box as we go through the presentation. It's my pleasure to hand the presentation now over to Stu Henderson. Stu?
Thanks, Yvonne. In order to talk about securing FTP, we're going to look at a little history and put a little context on things so that we can see what mistakes people have made in the past and how we can learn from them. And this is going to lead up to a call to action so that we can get an understanding of what we need to be dealing with right now. And along the way, we'll talk a little bit about how FTP security works, and we'll give you some examples just so that as we talk about the issues, you'll be able to apply them to specific situations. Here we go. Real basics now. The start is, what is FTP? It's File Transfer Protocol. It means two things. First, it means the set of rules for standardized transfer of files between computers, and this means different types of computers like Windows, Unix, anything over the internet, and mainframes also. FTP also means, a separate meaning but related, is the software that is running on those computers that makes the transfer happen. Now, a long time ago, I mean long time ago like in the past century, when people wanted to transfer files from one site to another, they'd print the file and postal mail the printout to the other site. People would do data entry on the other site off the printout, and of course it was ridiculously inefficient. It was slow. It was error prone, and we got wiser. Now what we did was we started copying the file to tape, and then we would mail the tape or send it in a delivery truck, and if someone stole the tape off the delivery truck, the question was, who's responsible for some evil person seeing our sensitive data? And Congress has spent a lot of time and energy, among other things, deciding whether the sender is liable or under what conditions he's liable, and they decided that if the sender had encrypted the tape, he wasn't liable, but if he had encrypted the tape, he wasn't liable. And then if the tape was not encrypted, the sender was considered liable, and so there were a lot of shops that various people, operators in the computer room, would be sending tapes out because they'd been requested to, and no one had informed them about the importance of getting the encryption in. So this was still slow and was also considered still insecure. Well, then we got to the modern age. Someone invented TCP/IP, and on top of that, they invented FTP, the file transfer protocol. It works on any type of computer you could name. It works cross-platform. I mean, from one type of computer to a different type of computer. It works across oceans among different countries. Now, some versions of FTP software support some types of encryption. Some support others. I don't think there's anything left in the market that doesn't support some encryption, but it's varied by product. But with FTP, this is considered fast and easy once you get things set up, because all you have to do is a couple of clicks on things and files get sent out over the internet, which is pretty nice. Now, in some organizations, we found that each user was able to implement whatever version of the FTP software he wanted. You'd download a free copy, or you'd buy a copy, or you'd get a copy from your friend. Everybody had different versions of the FTP software from different vendors, and as long as it worked for what he was doing, it worked great. Users also had lots more flexibility. Although the FTP standard was standard, the different types of encryption were not forced by the software. So users could not only choose which version of the FTP software they wanted to use, they could also choose how to encrypt it or whether to encrypt it. And again, they do, like any intelligent user, they do what worked for them, because if something's working for you, stick with it. This was still considered insecure and disrupted if the different versions didn't interact well together. And if users chose not to implement secure encryption, reliable encryption, and the definition of what's acceptably reliable encryption changes as the technology and the regulations change, well, then it was still considered insecure if appropriate encryption wasn't provided. So in some other organizations, more things we learned about problems that people had in the past. If two versions of the FTP software didn't work together, and sometimes they just would have differences in how they shook hands and how they talked to each other, well, the users would end up wasting a lot of time and getting frustrated. They'd end up just getting angry at IT because my computer worked fine when I was doing my stuff, and then when I had to talk to Charlie over there, it doesn't work and you didn't fix it, and I thought this was supposed to be standard. We also found, especially when we started talking to different countries, that different computers use different ways of encoding the data. There's ASCII versus EBCDIC. There's double byte character sets. If you're talking to someone in Japanese or Chinese, for example, you might be using double byte character sets. And if you get into the details of the order of the bits within a byte, some things were big endian and others were little endian. And the details of that don't really matter. What's important to understand is lots of different computers have lots of different ways that they can encode things, and you need to take care of the translation from one coding mechanism to another. If someone in New York is sending something to someone in Tokyo, they might be using all sorts of, if one is Windows and the other is Unix, there are all sorts of differences in the way stuff is encoded. So some more things people learned just the hard way. Users aren't going to activate encryption unless someone tells them to. And in a lot of cases, we don't know when users are sending files out or bringing files in. So they don't activate encryption, and we're not able to tell them when they need to do encryption because we don't know when they are using FTP. So what we learned from this is when it's necessary to have encryption, you need to make the encryption automatic and have it be automatically implemented anytime that it needs to be implemented. And that, of course, requires understanding when it needs to be implemented. Some more things that we learned the hard way: standardization for FTP, both within the organization and within the outside the organization, will make things more efficient, more secure, and more compliant with regulations. If you just say, within our organization, the same way we say if you're using our email, you should understand that we may be reviewing your email because it's part of our organization's IT infrastructure. If you're going to use our computers, if you're going to be doing functions for our organization and what our organization is doing for our business, then this is the FTP you're going to use, because we need you to be using standard, compliant, properly secured encryption. It's hard to manage FTP and FTP security if you don't know what files are being transferred. And if you think about changes that come in the regulations and changes that come in the technology, you're going to discover that, suppose you're a CIO and you learn that there's a new change. For example, the European regulations for encryption are changing and may apply to more American companies than people had first thought. New York State is implementing some new encryption requirements for financial organizations, and there are other requirements coming at us all, and there's PII and HIPAA and all the others. Well, suppose the technology changes or the regulations change, and you're a CIO, and you want to tell your people, oh, let's stay compliant. Let's make sure that every place we do encryption, the encryption is current, using current technology or meeting current regulations. Well, if you don't know where things are being sent from your data center, then it's hard to know where things are being encrypted, and then it's hard to know where to apply the new rules. So there's a little context, some things we've learned the hard way, a little bit of history. Before we go any further, I'd like to just get a common level set for us all in what FTP is and how it works. So here's some basics. If you know this stuff, we won't be long on it. If you want to download a file to your computer from another computer, the command is get. You get something from another computer. If you want to send a file from your computer to another computer, the command is put. You get something from another computer, or you put something to another computer. In the conversation, whether it's get or put, there'll be two computers, and one is always the client and the other is always the server. And the client, if you have trouble figuring it out, is the one that speaks first. So if you want to get or put a file to or from another computer, you'd start the FTP client program on your computer. So you've got your computer in front of you, whether it's Unix, Windows, or a mainframe. On your computer, you start the FTP client. And you tell it, go shake hands, maybe over the internet or however the communication is done, with the other computer, the FTP server. And second, you prove who you are to that server. And then you issue get and some other commands to request the file transfers. So we've got three security issues here once you've got this model in your head. First, how do you prove the identity of the other computer you're talking to, the FTP server? How do you know that it's really that server? Second, how do you encrypt data while it's going over the network? And third, how do you determine who can upload and who can download what files? Now, we've got all of those questions from the client point of view, but if you turn it around, you've got the same three issues from the server's point of view. How do they prove the identity of the client program? Who do they know that, how do they know that you are who you claim to be? And the other issues there. So to make this a little more specific, suppose you've got someone sitting at a Windows computer and he wants to send a file with FTP to a Unix computer. So our happy user sits down at his Windows computer, he logs on to his Windows computer, and on his Windows computer, he starts the FTP client program. We know it's the client because it's the one that's going to talk first. The Windows user tells his FTP client program to reach out to the server program over the internet. This is so it has to first find the Unix computer and then get a handshake with the FTP server program on the Unix computer. Now the Windows client program has a handshake or a session or a conversation with the FTP server program on the Unix computer. We hope that the Unix computer has its FTP program up and running. It should be sitting there waiting for some client asking it to provide service. Now the FTP client on the Windows computer, the FTP client program shakes hands with the FTP server program, and the FTP server program on the Unix computer is going to send a message back to the Windows client saying, log on, prove who you are. And in most cases what will happen here is the Windows FTP client program is going to turn to the user on the Windows computer and say, please enter user ID and password. And the user types them in, and the client program will send the user ID and password to the server program, and the user ID and password will be checked out by the server program, and assuming that everything is fine, the user at the Windows computer is now able to type in get and put commands to upload and download files. So we've got these basic questions. How does each computer prove the identity of the other computer? How do they handle encryption? And how do we decide who is allowed to upload and download what files? Now, you could repeat the example. You could change Windows and Unix to mainframes or AS400s. There are lots of different versions, but if you've got this basic example in your mind, that'll serve as a prototype for the rest of our discussion. We're ready now to wrap this up and give you a little call to action. When you implement FTP in your organization, you need to be thinking about a whole bunch of issues. First, how do you know what files are transferred and where they're sent? If you don't know this, if you don't have a way of knowing this, it's difficult to make sure that you're being compliant. It's difficult to provide forensic evidence. It's difficult to prove that you have taken all reasonable steps to provide security for your clients' sensitive data. Where is the encryption needed? Now, you might need input from your legal department or your compliance department and your end users, but where is the encryption needed? You need to figure out how to make this happen and how to enforce it so that wherever it's needed and whatever type of encryption is needed will be automatically applied. For terms of efficiency, many people say that what you want to do is when a file is transferred from one computer to another, to another, to another, to whatever computer it's ending up in, a store and forward process, you'd like to encrypt the file just once. It's more secure if the file is not decrypted and then re-encrypted at each point by each computer in the process. So it's simpler, more efficient, and more secure if you encrypt a file just once when it gets sent over several hops to get to its final destination. So some more issues to think about. You need to make sure that all the versions of FTP that you're using work together, that they don't have any inconsistencies, that one vendor does things one way and other vendors do things another way. You've also got the question of how do you handle automated batch transfers? Sometimes you don't want to just sit down and log on and type in whatever your specific request at the moment is. You want to set something up and have it happen automatically without your having to think about it. You want to say to FTP, every Thursday at 9 o'clock, send this file to Washington or wherever, and don't make me type the commands every Thursday. I've got other things to do. Just make this happen automatically in batch. Well, how are you going to handle those? More questions to consider. How do you ensure that all the logs and regulations that apply are identified and enforced? And again, if you don't have input from your legal and compliance departments and from the end user of your applications, you're probably missing some things here. When the regulations or technology changes, how do you identify all the places you need to upgrade if you don't know all the places you encrypt. Now, if you think about this a little bit, this means you have to standardize. You have to say, no one can use FTP except the standard version of FTP that we're going to use. And then you need to have a way to let that standard version of FTP that everyone uses for work-related stuff in your data center, that automatically keeps a log or somehow informs you of all the places that encryption happens. Every place you send a file, the to and the from, every place you receive a file, you to and from, what's encrypted and how is it encrypted. Otherwise, if the laws or technology or regulations change, it's hard to know where to go find all the places you need to do the upgrades. Some more issues to think about. You need to prevent data leakage. If someone has access to sensitive data and he's also allowed to use FTP, what stops any user in your shop from sending sensitive data improperly using FTP? Well, this is hard to control if you don't manage FTP, if you don't centralize or standardize what FTP people are using and at least have logging of what things are sent. But you also need to look at the whole consequence of how things are set up. If a user, the combination of a user being given access to sensitive data and also being able to FTP things, that combination will require at least consideration from people in charge to cover, to prevent improper data leakage. And another issue, of course, is does the FTP work cross-platform, cross-cultural with double byte character sets and any platform you want to deal with? And does it address all of the trans-border legal issues? And for these, if you're sending something to Europe or any other country, you need to get input from your legal department. Next set of things to worry about. How does each FTP verify the identity of the other user? We are now concluding that passwords are not sufficient. You need digital certificates or Kerberos or handheld tokens or some other way of doing it, but people are sloppy with passwords, and most people are starting to say passwords alone are not a reliable way of proving someone's identity. So if you want to force more secure identification of users, then you need to be able, again, to standardize the FTP software that you're using. Next, what user IDs are used for the FTP programs? Each FTP program itself will probably be running with its own user ID, and some shops, some people say every FTP program should have access to all files, give it privileges in your security system so that FTP can access all files, but what that does is open a great big hole, because then anyone who can use FTP can access any sensitive data and you've lost control of your sensitive data. And last, what degree of standards and enforcement is called for? So we've given you some things to think about. I hope this helps. Here's some additional information sources. And now what I'm going to do is turn the show back to Colin. Colin, take it away. Thanks very much.
Thank you, Stu, and thank you, Yvonne. Thanks to you for that trip down memory lane as well, and also the great food for thought you provided to our attendees today. Some of the questions you posed is a great leading to my portion of the webinar. Questions like, how can you prove the identity of the remote FTP server or the FTP server that you're communicating with? Also, from a visibility point of view, what FTPs are occurring in your environment. You need to identify these FTP transfers before you start deciding on what you want to start securing. So welcome everyone. Here's my agenda for the next 20 minutes or so. I'm going to briefly go over some of the facts of unsecured FTP. So I'm going to breeze over that and then talk about the case for secure FTP. My sales colleague and I were chatting the other day, and there's a huge uptick in the amount of interest from customers in securing their file transfers. We've seen unbelievable activity since the beginning of this year, so certainly something that a lot of customers are looking at. And my intention is to show you today, if you've been mandated to start using SFTP and you want to start migrating some of your batch FTPs to SFTP, and perhaps you don't have the manpower to start changing that JCL from regular FTP to SFTP, we can help you to make that transition so much easier by using the VFTP and SSH Tech Tier products. And I'll be doing a live demo on that in a few minutes time. So that's the demonstration. And also lastly, some of those questions that you may have, just pop them in the question box and we will address them after today's webinar. So let's get right to it. Some of the facts, like I said to you, you're probably familiar with most of these. One of the biggest advantages to FTP is that it's already available in so many different operating systems. ZOS, Windows, Unix, Linux, you name it, it normally is available and always ready to go. The client side is always available or nearly always available for use, and the server side is probably or usually pre-installed, and with a little bit of configuration you can get it up and ready available for use. Because FTP's been around for such a long time, as in fact Stu mentioned some of that, it was really interesting, and because it's so readily available, I think everybody on today's webinar has had some exposure to FTP. It's pretty simple to use, uses some common prototypes, and everyone, like I said, is familiar with the nice basic syntax and the fundamentals of FTP. It's been the de facto standard for such a long time, but I think today, in light of some of the exposures on FTP, people are looking at different alternatives. What are the downsides to using FTP? And certainly in some custom environments there may be a case where you may be transferring not secure information. There might be a reason why you could consider still using regular FTP. But if your FTPs are going outside of your environment or you're transmitting really sensitive data, then FTP should not be something that you're still using in today's time. You should be considering alternatives, and SFTP could be one of them. One of the major constraints using regular FTP is the very little security. So I would like to indulge you just for a minute and show you a live packet trace of a FTP transfer. Here I've got a packet trace running on port 21 on one of my FTP servers, and what I'm also going to do is I'm just going to bring up the packet trace definition. Here I'm ready, I've got the packet trace running on port 21. I'm going to hit the start button, and then I'm going to use a good old command prompt just to kick off a FTP packet trace. So let's do that, and the user I'm using is one of my test user IDs, and I'm going to enter the password, and now you'll see I'm logged on, and there you can see some of the packets that have come up from my logging on to FTP. So let's examine a few of them. There's the user ID BTID1, and there's the request to send the password, and lastly in the open you can see the password is secured for this particular user ID. So that's the password name that I've chosen for this user ID. So definitely not something that you should be using. FTP should not be something, the protocol you're using if you're transmitting some sensitive data. So let's get back to the presentation and continue with talking about why you should consider using SFTP. So SFTP has been also around a long time. It's point-to-point encryption. So let's just be pretty clear on this. SFTP is not the encryption engine. It is a subsystem of the SSH server, the SSH component that is actually responsible for that encryption. So SSH can encrypt lots of different types of traffic, including telnet, file transfers, and just about any type of TCP traffic that you require or want to secure. SFTP simply is that add-on that makes file transfers more convenient to run through an SSH tunnel. One of the nice features is it already comes with the base of Unix and Linux. So if you have those operating systems, you'll find that there is an SSH presence on those operating systems. What are some of the downsides to using SFTP? Whenever I'm working with customers and I'm doing a proof of concept, I will remind customers to make sure that they check with their Windows folks to see if they do have a SSH server or client running on Windows platforms. There's a bunch of them out there. For the most part, we interact with all of them as long as the product adheres to the SSH protocol. So a lot of customers use some of the software out there, and also some free ones, which works pretty well with SSH Tech Tier as well. One thing to mention, that base SFTP has some limitations, and I'd like to point out them. The one serious one, or the one that a lot of customers complain about, is that direct MVS dataset support. So if you're using OpenSSH, you know that the information will be stored in a ZFS file system. You would have to stage the data and then probably use the ocopy command to get the data from a ZFS file system into a regular MVS or ZOS dataset. If you're going down the SFTP route, bear in mind that the command syntax is different, and let me illustrate this quickly for you. Again, I'm going to switch to one of my sample batch jobs. This is one that I was testing here in my environment, which I can send to Windows and Linux and Unix platforms. What I'd like to point out here is the advice string at the bottom, so highlighted in blue. Here you can see some of the additional operands that needs to be coded inside of my batch job to use straight SFTP. So we're not talking about using that, which I'll talk in a minute about, the transparent no JCL changes, and I'll illustrate that shortly. So here you can see some additional operands. I'm using SSH Tech Tier, I'm using the SSH SCP G3 command, and the password I'm using, I've chosen to use password authentication. You can use the PKI, so public, and also certificate authentication. So we do support X.509, but here you can see that's the password in a secure dataset. And then there is some advice strings that needs to be added to this batch job in order to support straight SFTP. So the code pages and also the transfer file delimiters, and there you can see the name of the file, and I'm storing it in a MVS dataset. So that tells you that it's going directly to a MVS dataset. So just an example for you, if you were considering changing your batch job, there's some significant work involved, and you may require some additional manpower and resources to convert those batch jobs for you. So let's get back to our demo and continue with it. So now I'd like to talk about SSH and also VFTP. Quick high-level overview for you on the two products. SSH has been around for a very long time, since 1995. Tatu and the guys developed SSH, and it is the de facto standard used by folks all over the world. They took the product from the distributed side and ported it to run on the mainframe. Some of the features on SSH Tech Tier: it provides secure file transfer, which I mentioned, and also application connectivity and also system administration. Few key features to point out: the transparent FTP to SFTP conversion, native ZOS dataset support, so that's huge. You don't have to stage any data. You can elect where data should be stored immediately. We support the use of the crypto, that's a configurable item, configurable ASCII to IPsodic, so if you're sending from the mainframe to Windows, you can control that. We also support RACF, ACF2, and top secret implementations. And then we also cut a SMF119 record, which you then can get visibility on those FTP transfers. Some features of VFTP: Stu spoke about this, that visibility. VFTP is going to provide you with that visibility, so complete visibility of all FTP transfers, both inbound and outbound. Fail transfers, problem transfers, you can be really granular for the type of information that you want to view on the product. This is one of my favorites, the secured versus unsecured transfers. Gives you a nice breakdown of all the FTP traffic types on your system. So in my environment, I have 3 LPARs. I have an agent running on every one of those LPARs. They are reporting to a web server and database server, and I can get visibility on all of those 3 LPARs and also drill down individually on one of them. One of the other features of the product is the VFTP Security. Stu spoke about that as well. Perhaps you want to limit folks what access they have, what commands they have, so you can implement one of our a few of our FTP server exits. Once somebody has read access to a dataset, they can download it, and the subsequent dissemination of that data is not something that you can control. So you can control what directories and what files people are allowed to download by implementing our FTP server exits in conjunction with RACF rules or top secret and ACF2. This powerful site command might be something you want to secure as well. More importantly, with VFTP and our client rule in play, you can route FTP batch jobs to the SOCKS proxy with no JCL changes, and I'm going to get to that in a few minutes time. Auditing might be really important. Perhaps you need to keep FTPs for a significant amount of time. You can go back for a year or two and view the information from those FTPs. Another nice utility is one of our customers likes this. He produces management reports and he is able to extract information from the database in the comma delimiter format and importing it into an Excel spreadsheet and running reports from there for his managers. Last piece to talk about is automation. This is something that some of our customers exploit, not too many, but it's certainly available to you if you want. You can code within your batch job something called FCL, FTP control language. Statements like if, then, do, and else. You can say, all right, if this batch job failed, I want you to retry the operation, and then if that fails, wait 5 minutes, then post a message to the system console and also email folks on the production support team to let them know that the file transfer has failed. So that's an example of how you can use FCL in your batch job. You can generate and also alert warning notifications, also restart failed FTP transfers, and perhaps you want to be made aware of those really large FTP transfers on your network. We can alert you on that. So how does this all hang together, both SSH Tech Tier and VFTP? This is the complete solution. The VFTP client wrapper surrounds or wraps around the standard IBM FTP client, and that allows us to perform some of the functions I just spoke about. The FTP SFTP conversion is implemented using the Tech Tier SOCKS proxy component. The Tech Tier SOCKS proxy acts as a SOCKS proxy for the FTP client and also captures FTP connections based on filter rules. So within the proxy, you can configure some of those filter rules, like the destination of these, where it's going to, whether the command should be converted to SFTP, or if you want to use SSH tunneling, and there could be occasion where you want to use SSH tunneling. One example might be perhaps you're running SSH Tech Tier on this mainframe and you're sending to a mainframe that's running OpenSSH. If you configure the proxy to use an SSH tunnel, you then can configure OpenSSH and maybe turn on the allow TCP forwarding operand. That'll allow you to use some of the features that SSH Tech Tier has, like the direct MVS dataset support. Lastly, FTP connections are converted to SFTP transparently to the user and also to the FTP application. So just to wrap it up, if you've been mandated to look at converting your batch jobs, then this is certainly something that you may want to consider. It satisfies the SFTP requirement because all of the data, including the user credentials, are converted to SFTP, so nothing is in the clear. They are routed to the proxy and converted. You can still use the FTP client on the ZOS side, and you can configure FTP batch jobs to use the proxy. And big thing is you do not have to make any JCL changes. So let's get to the demonstration. I'm going to switch to VFTP. I'm already logged onto the product, and there is VFTP over there. This is VFTP. I'm logged onto it. Here you can see on the left hand side, these are the standard queries that the product gets shipped with. So it's a matter of selecting the appropriate one that you want to run, and then selecting a time frame. So I could say, show me for the last 4 hours, give me a breakdown of the traffic types on the SDS environment. So there you can see there's some using FTP to SFTP conversion. It looks like there's one of them over the last 4 hours. There's also a lot of unsecured. There was 251 transfers and also one transfer using SSH. So not the busiest environment you're ever going to see, but then again, this is a vendor environment. Let's choose maybe one more, just go back for a shorter period of time. Let's hit the get button. Still a bunch of unsecured FTP transfers. I clicked on that number 61 and now it's broken it out for me, showed me some of those transfers. So I can select any one of those. Let me give a bit more real estate to the bottom of my screen, and now I can see some of the details about this one FTP transfer that I've chosen. So a lot of good information here, and you can also view it if you drag your slider bar to the right hand side. transfer information, file information, performance information, and also session information. I can click on the session log and now view the context of the FTP transfer and see what specifically this user did. So pretty straightforward, not going to spend too much time on this. One other one that I will run for you, which always sparks a lot of debate at customer environments, is to see what files people are sending and getting from the mainframe from the remote network. So the same applies, seeing what the IP address is, and you can see what this particular person did. So let's get to the heart of the presentation. I'm going to click on the configuration tab. Let's click on the client, and this is going to open up the vital signs for FTP client configuration. Here you can see there's a bunch of rules that we've got here, and you can have as many as you want that performs a variety of different functions. Here's one for batch job name BCVR, and the question mark denotes any one character, SF star. So that's the filter I've set up for this one batch job, which does also looks like it's doing FTP conversion. For today's demo, let's use one that I've got set up already called FTP SFTP3. So I want you to remember that name, and it's in effect for only one agent. So the agent called STS1, I could also change it to different agents, and the job name that it's going to apply to. So anytime a batch job runs that matches ZFTP job star, this rule will be affected, and it'll then send this information to the proxy, or it'll be routed to the proxy, and the proxy will convert it. There's some additional parameters required in your FTP.data, so you can use your existing one, so that way you don't have to change any of your batch JCL. This came up in a question recently in one of my webcasts, a good question from one of my customers. Yeah, I've chosen to use an alternate one, so I've created a brand new one just for this transfer. And the two operands that's required to be added to your FTP.data is the firewall friendly operand, which must be set to true, and also the SOCKS configuration file, where you have some SOCKS configuration information about the transfers. So all stuff that is done prior to doing this testing, stuff that is documented, and also we help our customers with during the proof of concept. Something that's important is to make sure this is highlighted, so sessions for this job step should run across a SOCKS proxy. And now I'm ready to go and run my batch job called ZFTP job. So I'm going to close that out. Let's go back to TSO, and I'm going to split my screen. Here you can see there's a batch job called ZFTP job, so that matches the filter I've set up. As you can see, it is regular FTP. There's nothing, no SFTP command syntax in here. So BDJM, the password, doing a change directory to the user's home directory. It's a binary transfer, and then doing a put of a file, and that's the name of the file on the remote end. And I believe this is going to a Windows platform. So let's hit the submit button, and let's go and have a look at this batch job. So I'm going to go here and go to STSF. By the way, I've already got SSH up and running, and there's my batch job running. Let's go and examine some of the information inside of my batch job. So let's point out a few things which you'll remember from me showing you when I open up the VFTP client rule. There's the job name, ZFTP job. It's applying the rule. Remember, I pointed that out to you, FTP SFTP3, and now the rule is being implemented. This batch job was forced to the proxy, and now there's some additional information inside of your batch job. So something to be aware of. Perhaps if you're going through this migration process, some folks may say, hey, what's this new verbiage inside of the batch job? But something to be aware of. There you can see the user ID, and the transfer worked successfully. So I did not have to make any changes to my batch job. And just to give you a quick example, here's SSH is up and running. Looks like we've got a few of them running, some testing going on. This is listening on port 22, so that's one of the started tasks that you need up and running. And also the proxy, which is the one that does the interception or intercepting of the batch jobs and converting it to SFTP. So that's what it's all about, folks. Thank you everyone for your time.
Thank you for watching our VFTP SSH collaboration software video. If you have any questions on this product or any other STS product, You can call us at 1-800-443-6183 or send us an email at info@sdsusa.com.